All right. Thank you, folks, for coming. My name is Chris Iverson. I'm a software design engineer at Microsoft, and I lead the development team around 3D printing. And really, just how many of you guys out here already have a 3D printer, or you've built one or something? So you guys should get an award, I think, right? Because 3D printing is really very hard to do. So I got started in 3D printing about 2 years ago. And I did it by building a 3D printer from parts. You know, I went out and sourced them. It was a really great experience because I got to put this thing together and make a device that did something kind of magical. My kids loved it. But you know, I really wanted 3D printing to be easy enough that even my kids could do it. And so I was able to join the team at Microsoft that was working on this. And I think we really got pretty close. We really succeeded with Windows 8.1. And we demonstrated 3D printing in our retail stores in the United States with a MakerBot Replicator 2, talking to a Surface computer using our 3D Builder app. And it was a great demonstration of how easy it was for people to use a 3D printer. And for many of our customers, it was the first time that they had actually ever seen a 3D printer in operation. So today I'm going to show you a bunch of new partners and products and things that are built on the 3D printing platform. And I'm going to then spend a little bit of time showing you how you can incorporate the same features into your apps and prepare your devices for Windows. I'm going to talk about new stuff. Just about everything here is stuff that we haven't announced before or we haven't talked about before. And let me start first with 3MF. So as part of our work with Windows 8.1, we actually built a new file format. This is the format that our Windows APIs take. It's a file format called 3MF. And it was specifically invented for 3D printing, and we did it in close partnership as we approached Windows 8.1 release. And for the first time, we're actually going to publish this, so it's out on MSD and available to for anyone to use. And I believe that documentation is live as of about an hour ago or so. And you should really go download it and see. But 3MF has a couple of really important features that we didn't find in other file formats out there. Now, there's great file formats for modeling and CAD. There's great file formats for manufacturing, but there wasn't really a format that we found that blended the two together. So that's why we felt we needed to create a new format. And it's it's the format that's accepted into our APIs in the print system in Windows. It has some new features. It supports multicolor, texture, preserved scale. It doesn't have duplicate vertice problems like you might find in STL files. We think this file format is ready for the next generation of printers and a step forward for the industry. Now, we have broad partner support across the industry, all using 3MF. I'll talk about some of these products and partners today. And I'm going to start with plug and play. So plug and play is the thing that makes the device easy for consumers to buy and just plug in and have it work with Windows. We started with the MakerBot Replicator at this holiday season. And then we quickly followed up with the TierTime desktop printers at CES. And they support plug-and-play Windows drivers. And today, I'm also proud to say we're working with PrinterBot. It's another excellent printer company. And this is an excellent consumer line of printing devices, very simple to use. And in this case, Microsoft is actually providing the plug-and-play driver, the slicer, and the whole sort of end-to-end pipeline all the way to the device. And I'm really pleased to have Brooke Drum, the founder of PrinterBot, here to tell you more about the device and share some interesting stories with you. You're welcome, man.
All right, so my name is Brooke Drum, and I'm the CEO founder of PrinterBot. And I just want to tell you a little bit about our company. So about 2.5 years ago, I bought my first MakerBot, actually. And I set it down on the kitchen table, and I wanted to put that together with my kids. I got 3 kids. Because I really had this vision for, and not unique to me, but I wanted to kind of be the first family on the block that was able to put together a 3D printer together and print together, right there on the kitchen table. And I found out from that, and I've told Bree this, I found out from the very beginning that 3D printing is indeed hard. Making printers is hard. And so we sat there and we suffered through it, and we were able to print. And I decided I wanted to make this easier for people. I'm really passionate about kids and families, and so you'll hear me talk about that a lot, because I want to see kids and families use these printers, not just businesses. So it's always been my dream to be, since then, and it seems like ages ago, it was like 2.5 years ago. It was my dream at that point, well, I can build a printer company that makes it a little easier for people to be doing this at their kitchen table at home. And I really saw a barrier to entry as the price. So what I did was I did a Kickstarter. All right, I had some options, mortgage the house. My wife said no. I said Kickstarter, and she said, yes, that's what you're doing. So I put it on Kickstarter and was embarrassed to say, $25,000. I think I can build a $500 printer, and I can do it in my garage, and I can build 50. And at the end of the month, it funded $830,000. And I was shocked that people were interested in 3D printing. And they first wanted one that was inexpensive. So that's where I set off. And now just fast forward a little bit, I've learned a lot over the last 2.5 years. And one is that, yes, 3D printing has really started as a hard thing to do. And there's still parts that are hard. Building an inexpensive 3D printer is difficult. From the very first time, though, what I love about these things is the fact that it's not just a printer. It's something that you want to do. It's people, right? It's really the people that matter to me, and making it easier to use is an important part of that process of this 3D printing stuff. So I'll never forget just a couple of quick stories. One is the first thing I designed embarrassingly, it was a bottle opener for my beer. I'm a beer fan. So I designed this bottle opener, and I put it on Thingiverse, and I thought, well, that's it. I designed my first thing and shared it with the world in a few seconds. And I walked away and went around. It was like a Saturday afternoon. And I hear this ding on my phone, and I pick up my phone. And this guy, Thingiverse has this thing that says, hey, somebody downloaded your file. And I was like, no way. Somebody downloaded this file. I was able to share this file with somebody. And it turns out he sent a picture to me. And it was a guy in Australia that printed the little bottle opener that I designed on his boat in Australia on the other side of the world, and was enjoying his beverage with something that I designed just minutes before. It totally blew my mind. And I thought, well, wow, this is, in small ways, it's changing people's lives, really. I mean, he's having fun, and that's cool. But I really thought it was too hard. Well, I started to hear from people and what they're doing with the printers, and I wanted to show you a couple of examples. One is this right here. Now, this was another guy during my Kickstarter that said, I've got some challenges, and I really need something to help me customize things. And that's what these things are really good at, right? They're really rapid prototypers. And so doing one thing, one time, in a very customized way is what they do really well. It's interesting that, if you make 100 parts, the last part is as much as the first part, and so they're all really inexpensive. But this guy just wants everything around his house customized for him. Because this guy his name's Matt, and Matt was born without thumbs. And when you're building something, opposable thumbs is really, really important. So it's already very hard for him. And then his wrists are locked just a few degrees of motion. His elbows are locked with a few degrees. So he can't even get through his front door without some labor. And so he said, my wife is a designer, and she modeled this piece for me. And I actually think it was SolidWorks. And it was a beautiful rendering, and she modeled this key. It was actually like green. But I had nail polish that was my daughter's that was white, so I went with white. But anyway, he said, so she designed this for me so I can get through the front door. You put your key in it, and he goes over and he pushes that forward. And I'm like, man, I went over to my printers. I had like 30 of them at the time. And I thought, that little piece of plastic is going to make a difference in someone's life. And indeed it does, and even to this day, this guy's designing stuff with his printers. Now he actually makes printers. He formed a company that is selling printers in Australia. But I'm so excited that the fact that we've got something that's digital and moves around the world, like the guy with the boat, and it comes down and it becomes something that's real right here on your desk. So this technology gets me excited. So it's not only hard, I found out it's hard to make a cheap printer. It's hard to build these things. And we've got this new model now that we've kind of founded on kits. But indeed now we've started assembling printers for people. And what we found out is, well, we want to keep the price low, but we also want to offer these assembled models that are very, very easy to manufacture. And so this is the PrinterBot Simple. It is the metal version, and that doesn't mean it prints in metal. It prints in plastic, but it's made of metal. So this is the Simple, and The other thing that's hard about 3D printing is the software. At least it has been historically. I remember my first print on my MakerBot in my garage. It was with Windows and a piece of open source software, and it was pretty finicky, as open source software sometimes is. And so I've just done open source software the whole length of the company. Well, as you guys know, this is not lost on you, I'm sure. But you've got driver issues, you've got ease of use issues, and you've got, for somebody that's really into design, you've got the way it looks and feels that's sometimes a challenge. So that's been a sore spot for PrinterBot in its life. It's good that we're open. It's bad that we don't have a powerful team behind us to help us with drivers and software and things like that. Well, until recently, right? So I'm thrilled that the software is getting easier. But this Metal Simple, or the PrinterBot Simple, it's $599, and that is assembled. This is easier to use than it's ever been for us, for sure. These 3D printers sometimes can be finicky about leveling the bed and whatnot, but we've got this auto bed leveler that in the firmware, it probes the bed, and it can tell you where this plane is, and so the software can figure out, okay, where do I need to print? And so when it's printing, it's adjusting the height of the nozzle, and so if it's going downhill, and these are slight differences, right? But as it's going downhill, it moves the z-axis. So what does that mean? It means for you guys using these printers, you don't have to worry about, I got this flat, this flat, this flat, where's my micrometer? It's going to do that for you. And so we've been printing out there, and this is so much easier to use because it's metal, because we have the auto leveler, and the final one that I'm so excited about, because I have a customer service department, and we were previously installing unsigned drivers and trying to get people kind of all hooked up. I walked up last night, and I plugged that USB into the Surface, and it recognized it, and we were able to print right there. So the drivers are supported in Windows now, and I am so thankful to Chris and the team and excited about how much easier this is going to make people printing with the PrinterBot. And I know it sounds trivial because MakerBot had it first, but I'm a small company that started in a garage with a dream to help people, and now it's easier to use with Windows. I'm so thrilled. So I did want to tell one more story and pass it on to you guys. There's another guy that I met in my journey, and his name is Richard Van Ast, and he was a South African guy that he was a craftsman, and he had an accident, and he actually cut off part of his this finger and part of this finger, and so he was a machinist as well, and so he made himself this little mechanical finger that just used the bend of his little knuckle to be able to do a pincher movement. And he thought, man, this is pretty useful. There's other people out there. Remember I talked about the customization of one thing, one time. Everybody's different. We're all built differently. And so he got this idea, well, if I make this 3D printable, then I'll be able to share these models with people. And so he invented RoboHand, and this is a RoboHand. And now we're friends now. It's an honor to meet the guy, and we're friends. And you can print we can print this stuff on a MakerBot, on a PrinterBot, on really any printer. But I just love the concept because it illustrates so cleanly that we are changing the world with 3D printing, and the collective we. People that are passionate, that are interested, and now the tools are getting so much easier that we can make real significant differences, not just getting through the front door, but for the first time, the young girl that wore this for 9 months, printed in 3D plastic here, and then there's some medical plastic that's really safe, and stainless steel medical hardware. But this all comes together and allows this young lady to be able to play catch with her dad, to eat, where she never could before because she didn't have fingers. She only had a palm. And so that's one really great example of how one person's life can be changed by this. And I really look forward to this partnership with Microsoft, and thank you for the work that you've done.
All right. I think Brooke covered the basic specifications here on the PrinterBot slide. Now, at Microsoft, we look at all these great devices that are coming out now, especially not just in the consumer side, also on the commercial side. There's just been like an explosion of activity in Kickstarter and even in the big companies that make the really expensive printers. And we look at that and we combine it with these software improvements that we're interested in making, like the work we're doing with Brook for PrinterBot. And I think about that combination of that rapid advance in hardware and this new software that's really the thing that's going to define this next advance in 3D printing. So let me turn a little bit and talk about the software side. So we already talked a little bit about some of the file print stuff that we did for the holiday season. Recently, we had Autodesk announce Mesh Mixer. It's a very simple consumer application available for download on their website. It does some really great things. You can sculpt and paint. Autodesk is extremely strong in analysis, like model analysis. They can hollow a model, so it reduces the cost of a print. And they also integrated with Windows 8.1 print pipeline to provide that 3D printing experience as well. Now, we also have the 3D Builder application that I mentioned. We're announcing another major update to 3D Builder with some really great features. This is the Getting Started app for 3D printing, and it's available in the Windows store today. This update we'll have out in the next couple of weeks, along with the driver work that we're doing for the PrinterBot. And I've got Steve Olson, my colleague, here to actually go through the demo of our updates so you can see what's coming.
Okay, am I on? I'm not on. Okay, so I would like to talk about 3D Builder for a moment. And if I can change it here, perhaps you'll be able to see it with me. So this is 3D Builder. It's kind of interesting that it's called 3D Builder because up to now it's sort of been 3D Viewer, and it doesn't give you a lot of capabilities to build. But we expect to be doing a lot of changes in 3D Builder moving forward. So we've added some new features. It'll be coming out in the next couple of weeks. So you should go, this is a Windows app. It's in the Windows Store, and it runs nice on the Surface. Let me start out by saying these are my tools for editing. I have a keyboard hooked to this Surface. This is just a Surface 2. I have a keyboard hooked to it, but the only reason I'm going to use it in here is to type in some text, and you'll see when I do that. So we've really focused, this is really focused on the non-technical user. It's focused to be very easy. This is something you want to give to your kids and have them go through and do a bunch of experiments. So let me show you why. So I'm going to start out with just a box on the platform. So I can rotate it and look at it. It's kind of a pretty simple thing to learn how to do. I can scale the box, and I can scale my view of the camera, and I can move it up and down. Really pretty easy to do. If I happen to get my box kind of out of whack, like this, I could do a lay flat, and it puts it flat on the bed in order to prepare it for printing. So that's kind of nice as a starting. But I think what I'd like to do is I'd like to add, I really should have brought some glasses, but I think I'm going to add from the library, I'm going to add this rocket ship. So it's kind of interesting. It's a little bit big. I'll shrink it down. So I'm going to not shrink it down too much. What I'd like to do is make a mold. So I've put the rocket ship in the middle of the box on purpose. So what I'd like to do is I'd like to use our capabilities to make a mold. So first I'm going to select the box. I can't tell if it's selected or not. Yes, it is. So I'll select the box, and I'm going to do a Boolean operation. And by the way, we're going to change the name. We're not going to call it Boolean because we're going to call it merge or subtract or something. But I'm going to do a subtraction operation with that device. And then what it did was it subtracted the rocket out of the box, which is kind of nice because if I were going to make a chocolate mold or something like that, that would be a nice way to do it, assuming that I didn't leave it full of holes for the purpose of showing you, for the purpose of this demo. You could actually do the same thing with the box covering it, and then you could put chocolate in it. But it might be easier if I did a plane cut. So let's take a look at this plane cut. There's my plane, and as you can see, it's kind of cut right through the middle of it. And I could move it up and down like this, and it will adjust as necessary. But since it's a mold, I would rather rotate it up on the side like this. And then I can tell it here, I want to keep both halves, but here again, for the purpose of this demo, I'm not going to keep both halves. I'm just going to let you take a look at it, and then rotate it around like that, so you could see that it actually did the mold from the inside. I'm only using my fingers here. There's no math involved. This isn't a complex technical problem. This is something you should be able to give to your kids. So now you notice that because of the cut, I've made it an unprintable object, and that happens when it's not manifold or when there's areas that are defined twice, and so it's not printable. And I actually don't think I'm on the internet here. If I push the repair button here, it would repair that. We have a partnership with NetFab and a service that's running in Azure. So it'll upload the model, and it'll repair it, and it'll bring the model back down. And that is this button here. I will try it, but I don't think I'm connected to the internet here. So anyway, that's sort of my first example of showing you how easy it is now to do a 3D object modeling. So what I'm going to do is I'm going to go back. I'm just going to discard this, and I'm going to do something else. My next demonstration, I'm going to do a trophy. So I'd like to start out with, the trophy might look nice on a cylinder. So there's the cylinder. And it's a little bit small for my taste. I want to make a big trophy. And then I'm going to use our emboss function. So I'll go to Edit and Emboss. I'm going to emboss text. Here's the point. I'm going to use the keyboard. I'm going to put in Chris is our def manager. I'm going to make a trophy for him. And he always tells me how great he is, so there you go. We're going to make it Chris the Great. But what I've done is I've done a planar projection on a cylinder. And so I think I'm going to change the projection type to cylindrical. That way I can rotate it. It kind of wraps around properly from the projection standpoint. You can see it a lot better. So I like that. I could change the depth. I could make the emboss go inward, outward, high or low. But I think I'll just leave it like this for the time being and accept that. And so there it is. There's my emboss. Pretty clean and easy. On top of this, I would like to perhaps add from a file. I have a file in here that's a nice pedestal. Let's open that up. There's my pedestal, and it's a little bit big. So I'm going to scoot it up and shrink it down to about there. And then I'm going to raise it up on top. Yeah, went the wrong way with that. So let's move it. I'm going to raise it to the top of the pedestal. I didn't get it completely centered, so we'll do a little better job with that. And there. So now the pedestal is sitting on top, and now an appropriate top for that, I think, would be a horse, since Chris is such a stud. So I'll take a little horse there and shrink him down just a little bit and raise him up. So there we have an almost right horse. Put him down like that on the top. There, so now I built a little trophy, very easy to do. So if your children are playing in a Little League or something and you wanted to make them trophies and put their names on it, these pieces, I found most of the pieces on Thingiverse. And so I brought them in and I've just used them as is. I didn't have to do a lot of design with it. It's really oriented towards people who would do something simplistic. And so the last thing I want to do is I want to select all the parts and do a Boolean to union those guys together. And then from there, I could do a print, just like that, and it prints to the Metalbot simple. Unfortunately, it would take several hours to print this, so we're not going to make you wait through all of that. But the point that I wanted to do, it's very simple. It has the repair service built into it. It allows you to import objects and very simply put together things, you know, cookie cutters and chocolate molds and trophies and a lot of editing capabilities that's very simplistic that you'd be able to use and make little things. So enabling the consumer stuff, We also have a lot of features that we'll be talking about which are really helping, that we're going to be putting in to help the enterprise work much better so we can work with the $1 million printers as well. But this is what I wanted to get across today.
You want to attribute? Attribution?
I don't have it.
Okay. So I was chuckling there a few minutes ago because the last time Steve did this demo, he wanted to show everybody how to do planar cut to cut the head of the horse off so that it was the horse's butt trophy for Chris. So thank you for not doing that, Steve. I appreciate that. Do I need to do something to switch the slides here? It's just one. So again, this app that Steve showed isn't yet on the App Store. It's not available yet, but there is the previous version, which is still a great version, that's up if you want to try it and see. Now, a couple other things that Steve didn't mention. We are very excited about scans. That's something that we talk a lot about in the office, 3D scanning. There's been some great scanning devices that have come out, especially in the consumer market, just in the last year. So we did test and make sure that the features that Steve showed work well with scanning. We use planar cut actually to cut features off, like faces, for example, and to clean up models. Automatic repair, for example, is another great feature with scans because you get very complex meshes and you need to turn them into a printable volume. We support full color, and that, again, will be passed through our 3MF file format to printers that could handle them. Here's another example of a head scan that I took. And again, I used the planar cut feature, and I cut off the face. And I just joined it using the Boolean union function that Steve showed to this Nokia phone stand. And it was fun to do, and it was a few swipes. It was really, really simple to personalize an object like this. It's something I would print and use. The model repair service is another thing that Steve mentioned. We have it as an automatic feature in our 3D Builder app. It's also available today free for consumer use as a web service. You can use the QR code there and take a look at it. This is in partnership with NetFab. NetFab has run a free repair service for a long time. We're now co-branding that and running it on Microsoft Azure. So please take a look at that. We're also looking to build this into a commercial offering. So if you're interested in integrating this into a workflow or into your business or app, please let us know. We have contact information at the end of the slides. We'd love to share that with you. So we've talked a lot about the consumer side. That's certainly an area we're very excited about. But we're not ignoring the commercial side, the professional side either. Even at Microsoft, we use 3D printers to prototype our hardware, like Surface and Xbox accessories. And the whole idea with the desktop 3D printing is you can iterate at your desk on something simple using simple materials. And when you're ready, you can take that same model and you can then print it to a commercial printer. So I've got Vajrang from SolidWorks here to talk more about the commercial software space, and he's got a great demo to show you.
Thanks, Chris. Let me just log into this thing here. What I want to. There we go. All right, thank you all. So how many of you know what SolidWorks is or have heard of SolidWorks? A few people, okay, good. So, we've been around for a little over 20 years. We are the leader in the mid-range CAD space, as Chris mentioned, in the professional space. So one of the things that people obviously do with SolidWorks is create the design from scratch. So this is meant more for designs like such as these. And this is the Holmatro Jaws of Life used by emergency responders to tear open car bodies or vehicle bodies in an accident or things like that. So I'll show you a few things here, how we've integrated the SDK that Chris talked about into the SolidWorks workflow and how we expect SolidWorks users to be using it. And we have a few comments on how easy it was actually. So quickly jump over to, so one of the jaws here, I have this open, this is just a single part. So one of the things we've done, in addition to the traditional print to paper, we just have a print 3D. Right? So as you can imagine, if you've got a PrinterBot, MakerBot, any printer plugged in with the driver stack from Windows 8.1 running, you see the list of printers, right? You see the print volume that we detect You select which plane is going to be the bottom of the plane, of the bottom bed of the printer. You can adjust the orientation so it fits correctly and things like that. And obviously, we'll automate some of this. You can add things like what the infill volume should be. How dense do you want the infill to be? Do you want to add supports or rafts? All these things are taken care of downstream by the driver, okay? So from a SolidWorks user standpoint, all they're doing, think about this, is file print, a couple of options. You hit OK and start printing. We have it running in the 3D print booth. You can come by and take a look. Any questions, or are we holding questions at the end? Questions at the end, okay. So something that was kind of exciting to me, little meta for all you geeks in the crowd, I guess. Some of the key components of this PrinterBot Simple were designed in SolidWorks, right? So when I was talking to Brooke this morning, he actually sent me, this is the print head.
The hot end.
Hot end. So this is the hot end right at the end that was designed in SolidWorks. So one of the test prints we did was, we'll be printing this with the printer that, the software that was designed using it. It's kind of nutty if you get it. But anyway, this is kind of very simple. So to talk about the SDK side of things, we've been working with Chris and his team. We got the SDK, and integrating this was really dead simple. We create the 3MF format, as the format that Chris mentioned before. We bundle it into a manifest. We include properties such as the material properties, colors, things like that, and we basically hand it off to the spooler. And the rest of it is as simple as you can imagine with a typical paper print. Okay, I think that was it. Okay. So, right, thank you.
Thank you. So we actually just hooked up the demo that Vajrang had to the PrinterBot, not, what, hour and a half ago or something? And we printed something. So if you want to come by and see the very first print from SolidWorks to a PrinterBot, you're welcome to come by our 3D printing booth. And we actually have this on video just in case we had any technical glitches, so I'm going to try to just skip over that. Okay, so now you've seen what a bunch of our partners here have done, PrinterBot and SolidWorks and our own 3D Builder app and Autodesk. So you're probably wondering, how could you take advantage of this in your own products? So I'm going to show you, first I'm going to talk about the SDK. So we do have a 3D printing SDK available for download. This is where our 3MS specification lives as well. It includes a bunch of samples, like source code for a desktop application. There's a full Windows Store application, a bunch of great sample libraries. In fact, there's a library in there to do STL to 3MF conversion, so you don't have to do all that stuff yourself. And I'm just going to kind of zoom in on one sample that we just recently added. And this is a very simple application. It was just built using the Windows Store template that's in Visual Studio. We extended it to provide a WebGL renderer. And it's using JavaScript. And we have a 3D printing function, a WinRT API, that just takes a print. It's called print. It just takes a 3MF model section. And the app looks something like this, right? It's just a cube, very simple. It actually rotates if this was a real live app. Oops, and it has a print button. The print button is wired to this JavaScript. And if you can see it, there is one function that takes the stream of data, and in this case, it's formatting it as a 3MF stream, and it's passing it to our print function. And when that happens, it triggers exactly the same user interface you would see in our 3D Builder application or any other Windows Store application that uses this feature. And that's it. That's how easy it is. And I really don't think I could make it much easier than that for you. If you're interested in preparing your device for Windows, there are some things you should know. We do have this 3D print driver that we're working with Brooke and his team on that's available. You'll need to make sure your device has the right firmware stamp. If you're using USB, we need to have a vendor ID and product ID that's assigned by the USB board. That's kind of the starting point, because now we can recognize you and your company and your device. We can assign device drivers to it. We also have the ability to support network printing through something called WSPrint, which is a standard used in the 2D print world. We have a WSPrint sample in the SDK for you to look at. It's a fully functional kind of standalone thing. And that'd be a great place to start if you want to try that out. And then finally, to get that plug-and-play device driver on Windows Update, there is a certification process that all hardware has to go through. That's a place you're going to have to partner with Microsoft There's a bunch of checks we need to make to get that certified and propagated. So when you're ready with your device and with your connectivity, you need to come talk to us, and we'll help you get that thing up. And then when you do have the plug-and-play driver available, and a customer plugs this device in, you'll see that your 3D printer shows up like a device, like a printer, in the hardware view in Windows. And that's it. That's all we have for you today. There's a lot of really new things there. I think there's some great stuff for you to take away. Download our 3D Builder application. You can check out all our information on our 3D website, microsoft.com/3D. Download our SDK if you're interested in incorporating 3D printing into your app or preparing your device. And then check out our model repair service as well that's out on the internet now. And with that, I guess we're open to questions and answers from you all. Yes?
Is the driver you're talking about, is it network shareable like other printers, or is it?
I'm sorry, repeat that again?
Is it network shareable like other printers? Like, can you have a workstation and a 3D printer?
So the question was, I think, is the driver that we have available network shareable? So there is a WS Print sample in our SDK that provides network, let's call it network printing. There is a concept called print sharing in Windows, which is more like print server. Print servers are not enabled right now, but that's something we're looking at doing in the next version of Windows. But you can use the WS Print class with your device to have many people print to the same printer. So that is still possible. Other questions? Yes, sir. Yeah, so the question is, there's a big class of devices that are RepRap-based printers, and he's asking if there's a Windows driver that supports that. So actually, RepRap, I mean, that's where I got started too, was building a RepRap printer. There's the Marlin firmware, which is the most popular firmware in RepRap today, is actually what's on the PrinterBot now. The issue with RepRap is it's not a company, so it doesn't have its own USB identifier. Anyone who has a RepRap variant that is a company like PrinterBot can get a USB ID assigned, and then we have a driver that would work for that device. In fact, we have a wide range of those in our office that we test and play with today. What we need is the company relationship to kind of actually deliver that plug-and-play experience. So yes, it's technically possible, and I'd love to support it. We certainly, we're very supportive of the open source firmware side, and we want to make sure that works really well with Windows. I'm not very happy with the inside driver situation we have now. We think we can fix that, so yeah.
If I can add to that, just
Yeah,
quick.
go ahead.
Since I started with RepRap 2, my company is an open source company. The electronics that run the PrinterBot, they're open source, totally open source. The firmware is open source, and even all the way down to the Gerbers. So there are people all over the world printing on the PrinterBot, printer board is what it's called, electronics. And so I will be very interested to see if I'm making, and we're making a lot of people happy that are technically not really printer bots. But I think I certainly want to be a voice in the open source community that we should work with Microsoft to make this happen for the users.
Yeah, I know.
Yeah.
Yeah, we can help. Other questions? Yes, sir. Yeah, so the question was, will 3D Builder support dual print heads? It actually does today. We haven't found a printer we haven't built a driver for a printer that supports it. In fact, one of my demos I didn't bring today was a print that had support material printed in a different material than model material. So it's technically possible, yes, but we haven't delivered that. We haven't delivered a device that supports it yet. But I'd love to.
We are going to send you one with two
Yeah, so
heads.
Brooke says that's the next thing we're going to do. So
Yeah.
if you have a device like that, I'm certainly really interested. The few that we've played with, especially with doing soluble support material, we found that the print heads sometimes need to be tuned differently, and often the print heads need to be designed slightly differently to do that. So it depends on the device, but the technical capability exists. Yes, sir. I'm sorry, I didn't hear that. I mean, AMS is a format. It's an open standard today. It doesn't pass through our print system in Windows. We have different technical requirements for our APIs. So I mean, there's no reason today you couldn't take an AMF file and actually load it into an app and print with it into our system. But we couldn't incorporate 3MF as it stands right now. Certainly, it's an open standard. We encourage people to use it. Yeah. Other questions? Yes. So in 3D Builder is actually using, I'm sorry, the question was, do we have libraries for 3D Builder available for others to use in their apps? It's sort of an interesting answer. It is based on DirectX, and we built a desktop sample using the same libraries, which we did publish inside our SDK. So many of the functions are there. I personally think that most people find the WebGL sample an easier place to start. So we have both of those samples available, though. But we didn't publish all the 3D Builder source code. But the core functionality that enables the print dialog and the printing, that's all inside our SDK. So the slicer, today we don't have that published. It is libraries available to use, though. So you will find the slicer libraries in our SDK in a compiled form. And you can incorporate that into your own driver if you proceed in doing your own thing. And that's in the SDK as well, yeah. Other questions? Yes? Okay, what is the price of 3D Builder for home and consumer use? So actually, it's free today. The 3D Builder app is a free consumer app. It serves as our getting started app and the demonstration of what we think the print pipeline should be for everyone. It will continue to be free, yes. The one exception there is the model repair service piece. Within 3D Builder, that is a free component. But if you want to include model repair in your own application or inside your own enterprise, there'll be a license for that. Yes, sir. Yeah, in fact, the slicer libraries, I'm sorry, the question is, could we have a driver that generates just standard G code and then it lets anyone use it on their printer? So actually, the SDK sample that we have now, the driver that's in the SDK now does actually produce G code. The catch there is that it doesn't do the plug and play piece, which we think is one of the big advances. So it is, we have the technology right now to generate G code for any printer. It's customizable in the sense that there needs to be a pre and post set of commands. But we think it's the plug and play piece that makes this a unique thing for Windows. So we want to do both of those. Those are great questions. Anything else? Yes, sir.
It's going to be in the next couple of weeks, probably 2, but it could be as much as 3. If you download it now, then you can get the update when it comes out. You'll be notified.
Other questions? All right, thank you very much. I'm going to be at the Expert Zone today from 4 to 6. So if you're interested in just having a one-on-one discussion about 3D printing, I'll be available there. Just check in with the receptionist and let them know. And thank you.